Look, I want to thank Micron for giving me this honor to present to this amazing forum. You know, digital transformation is at the core of what we do at Tata Communications, and so we're very excited to be able to share our views with the community in terms of what we see in terms of how, you know, the emergence of edge compute and its impact on in terms of IoT deployment, and also in terms of how the role of connectivity and security is impacted by all of that. So this is what I'm going to be focusing on, and you know, this is something I think that will address some of the reasons why we don't think IoT hasn't grown as fast as we originally expected, but I expect that to change quite quickly over the next few years. Okay, next page. So taking a step back, so I think right now we are in very challenging times, right? I think every company is facing economic difficulties. Even the top there, everyone is facing some challenges. And as a result, many companies are actually curtailing expenditure significantly, right? They want to be able to handle through the crisis and be able to survive. But if they had money to invest, it's interesting that where most of their money is being invested in is in digital transformation. I mean, that McKinsey did some really interesting survey, and basically they're saying is that, you know, from this crisis, what's resulted is the importance of corporate agility and speed. The ability to adjust to, you know, rapidly changing environment is critical to survival, right? And this crisis, this COVID is showing that not only is it changing things short term, it's going to have significant impact long term. And the companies that will be able to adjust to those changes are the ones going to survive. And as a result, everyone's thinking about, well, I need to be more agile. Digital transformation is a key enabler to that. And everyone's thinking about how I can invest or further you know, adopt some of those processes if I had the money to do that. And this chart here, where McKinsey again surveyed about the top 900 executives for the large corporates around the world, and they were looking at what percentage of your business today is digitized, right? Are you using digital technology in terms of your service or your products? And they looked at it pre-COVID and post-COVID. And you can see here, you know, across the different regions, there's significant jump in terms of the level of adoption of digital tools for their services. And we're talking about acceleration of at least 6 years, right? So in some cases, 10 years for Asia Pacific. Asia Pacific tends to be a little bit slower, I think, to some extent. So can you go to the next page? What are people investing in, right? And I think we're seeing is that they're looking at external areas like improving ways to earn more revenues, finding ability to, you know, enhance the agility to respond to changing customer behavior, as we talked about, improving customer engagement and service experience using, again, digital tools. They're also looking internally how, of course, to improve productivity, reduce costs, but also to enhance collaboration. Everyone's working distributed. Everyone's looking to, you know, working remotely. Security becomes a much bigger issue. And of course, always everyone's looking to improve safety wherever they're working in terms of, especially with the pandemic, safety becomes even more paramount. And IoT plays, I'm sorry, just not quite. IoT plays sort of a big role in that because it requires a lot of these type of transformation requires a significant or massive amount of data, and that data is going to be coming from the IoT deployments. And that's what's really, and using the data is going to be able to help them to gain the insights, to better understand the customer needs, and to be better improve the employee engagement in there. So data is a big part of this, and that's why I say IoT is also a big part of this digital transformation. Okay, next page. But the challenges in terms of IoT, as Chris mentioned in his previous presentation, in terms of the different things, in terms of the time it takes to do analytics and AI applications, the connectivity, all of that, are the real challenges. And in our view, some of these real challenges are things like making real-time decisions, right? People need solutions that addresses being able to adjust if there's something wrong in the factory, or there's something addressing the safety of an employee, or something to predict what's happening in a retail store. You need real-time decision, real-time results, and it requires a lot of compute of data, significant amount of data locally, right? Either because it's faster to do it, or because compliance reason requires you to keep the data locally as well. So I think the importance here is that without having, you need these sort of edge applications where it allows you to have real-time speed with local compute, local data to be able to solve some of these problems. And imagine taking a 4K video feed in the store, trying to figure out what's going on with the customers using AI. That's a lot of compute, and to make decisions like that in real time requires local resources. And that's what I think ultimately will drive IoT adoption, is because these solutions now are starting to come into place, and they're starting to be able to be proven and actually making an impact with the end customers. Next page. So just to keep the definition, there's different ways of interpreting edge. And there's what we call the edge, the edge, which is at the device level, or at the on the premises in terms of where you have the gateway, the compute clusters are. And then you have sort of the near edge, which is the network pops, the lampposts, the power stations, and then the far edge is where central office or metro pops, and beyond that, clearly you're going to the public cloud. And depending on where you are in the edge, it impacts the performance and the need of the applications, right? So as you go further and further to the edge, you could get lower latency. And as you go farther from the edge, the latency it drives. But there's a trade-off here. And that trade-off is ultimately by the needs of the applications and the economics. As you go further away from the edge, as I mentioned, the latency becomes higher and higher. But at the same time, you have a greater opportunity to share the infrastructure, right? And you can share the base station or the power utility or the far edge with other customers. Your costs can be lower and also greatly scale. So it's similar to a big cloud, but this is sort of a distributed cloud. So when we talk about edge, there's a lot of different applications in edge. So I just want to be clear that where you are in edge makes a difference as well. A lot of things that we're talking about for compute edge is really moving all the way to the embedded device area, where you have the greatest need and the biggest impact. Next page. So what are the benefits of edge computing? And we'll go to the applications, but some of the real benefits are beyond the fact that it reduces the lag, right? So you need to be able to do real-time applications, and you're moving the compute and the data much closer to each other, so the applications are actually more efficient. But you can also reduce costs significantly in terms of how much data needs to be sent back to the cloud, right? Because you're collecting a huge amount of data, particularly if it's a video feed or it's sensors that are collecting milliseconds of data at a time. A lot of data, and it's also needed to be able to connect it to the cloud, so the connectivity costs, the data storage costs can be reduced and to only what is necessary, and you can do a lot of these things at the edge. There's also compliance reasons where some information has to be kept at the edge, or they're secure. It's a much more security reasons why you need to keep stored there, or it's a much more secure to keep in one place rather than sharing in the cloud. And also at the edge provides a certain level of contingency also, because in some cases where you don't have connectivity, you're completely off the grid, either full-time or at least temporarily, a lot of the edge compute can go on and do the things it needs to do without necessarily needing the connectivity back to the cloud or to some centralized decision making. So that allows you to do, I mean, for example, one of the things people know is when Google first built their connected car, driverless car, they actually designed it so that it is without internet access. Everything is done in the car. All the information is stored there, all the decision making, the LiDAR is all done in the car. It's only very temporarily would actually have internet connectivity. So that is actually a use case where you actually have to plan for maybe even being off the grid. And edge compute addresses some of that needs as well. Next. Now, in terms of the various use cases, we see a lot of emerging applications and platforms that are making real impact with end customers. I think Chris mentioned a lot about manufacturing, but we also seeing things in terms of retail where a lot of applications are looking at smart inventory and being able to use cameras to predict customer behavior, predict customer buying patterns, being able to automate the whole customer buying experience so that it is as seamless and minimizes lines and doing it as quickly as possible and actually minimize the time they need to be in the store. There's also platforms which are using AR, VR to be able to simulate the trying on of the clothes. You can be able to visualize what the clothes will look like on you without the need of trying it on. And those are the type of experience that can be augmented with edge compute capabilities in the store. Auto industry, we're seeing a lot of activities there already. Many cars are coming with at least 1 or 2 SIM cards, collecting information about not only the telematics, but also in terms of information about the car performance. And also we're seeing the users, the drivers in the car, actually using the SIM cards for their own applications, around entertainment. And we're starting collecting data and seeing that growing already. And this is just starting right now. And we think that once you move to a driverless car and with 5G, that totally changes the game in terms of the amount of compute and data that's going on in that scenario. We're seeing also a lot in the area of media, where you have live content, and a lot of content now is being streamed over the internet. And so people are looking at edge compute to be able to improve that user experience. It's just like a dynamic caching, or actually be able to provide very live performances as close to real time as possible, because gaming or betting is also very popular, and so people want to make sure that certain things are being streamed. It is streamed as much in real time, so to minimize potential arbitrage in betting situation. So there's definitely interest in there. There's also in the gaming, where people are looking for improving interactive experience in gaming, interactive gaming across borders. Right now, you can do it with people around near each other or in the same server, but once you start trying to do it globally, performance deteriorates significantly. We think that edge compute can significantly improve the user experience there as well. Like I said, Chris mentioned already around the factories, the things that can be done there. We think there's significant opportunities to improve productivity within the factory, using cameras, being able to improve quality control, address worker safety, a lot of things that are already starting to be looking at and already in trials with customers. Again, a lot of these things, I think, in healthcare, in construction, in mining, there's a variety of new applications popping up, ones that are actually being proven where there's data that they have tried using machine learning. They've tested the data. They've actually coming up with performance where actually can deliver actual improvement of either performance or efficiencies for the customers. And many of these applications actually involve using a video camera, which have significant amount of data infusion. So that is what's the key driver. And I think with the maturation of all these applications and platforms, and people starting to see real success from them, the adoption goes up, and at that, I think will accelerate IoT adoption even further. Next page. Now, 5G is also going to be, I think, another big enabler, although the reality is it's going to take a little bit longer for 5G to be deployed on a global basis, but it could be a big game changer in terms of edge compute. Not only are you going to be able to get faster data speeds from the 5G, you're now working to a single technology for both the WAN and the LAN. And so that makes the simplify and the scale of being able to do things to address some of the connectivity concerns around the IoT and edge much easier, because now you have a single platform. Not only is it fast, but it also brings with it carrier grade performance in terms of security, in terms of performance quality control. So I think that the 5G will definitely have a big impact, and a lot of people already are exploring this. But again, I think this will take some time for it to actually come to place. But it will have a pretty big impact, in my view, for edge compute and ultimately for IoT deployment. Next. Now, Chris mentioned quite a bit in terms of market sizes, and the numbers, as we've seen from everywhere, everyone has slightly different numbers. But what I want to make here is that on the edge compute side, it's still very early stage. Today we're talking about a 9 billion industry, which we expect to grow to about maybe 30 billion by 2025 at a CAGR between 25 to 54%. This is sort of a small part of the broader IoT market, which we think between 1 to 1.6 trillion. Again, also very fast growing. But it's end of the day, it's a lot about the applications, the actual use cases that will drive adoption, right? And so you may have a lot of data, but it's what you do with that data that's critically important here. And it's the edge compute applications that will hopefully will be able to drive the big digital transformation gains that what the customers want in terms of improving their ability to understand customers and create new revenue streams, improve efficiencies. So that's why we think that with the emergence of these platforms, with these proven platforms with proven track record, with data which they have practiced and built train the data to be able to do specific AI applications, that we're seeing adoption starting to take place. Like again, right now, most people, if you talk to most companies, you'll get numbers like 60 to 80% of companies touching, dipping their toe and doing edge compute. But in terms of real adoption, we're probably still probably 1 to 2 years away. But when it does happen, we do believe this will accelerate quite quickly and has a big impact on the overall industry. Next. Similar to what Chris was saying in terms of, we look at the value across the stack, right? This the edge compute stack. Where the value really lies is really mostly in the areas of the platform, of the applications, and in the managed services side. The connectivity, the end devices are a smaller part. It's really the importance of the application. Is it really delivering the results? And if it is, that's when corporates will start, adopting and driving these things. And that's why I think we're starting to see that now, and you'll start hopefully to see acceleration over the next couple of years. So companies will always have to be constantly balancing the need of how much they want to do in the cloud versus the agility that they require at the edge. And there's an economics equation and there's performance. And so this is a constant balancing act that most enterprise will have to go through. Next page. So the key challenges, right? And some of this is similar to what Chris mentioned in his previous presentation. The connectivity is important. The simplicity, the ease of onboarding the solution, the hardware. Security is very important, as we all mentioned, and the fact that there's the complexity that we're talking about here in terms of, especially if you're trying to roll out a solution on a global basis, and there's all sorts of different things you have to worry about in terms of things at the edge, connecting it to the Wi-Fi or connecting it to the local LAN, and then going to the cellular player, being able to go into the different clouds, one cloud for the authentication, another cloud for the application. There's all sorts of routing the issues you have to worry about. And of course, the data is there's a hybrid data. So some data will be stored locally, some will be stored in the cloud, some may be stored in near cloud, and being able to manage all of that is quite complicated. And those are sort of things that we've been trying to address in what we're doing at Tata Communications. Next page. So one of the things that we talk about on the connectivity side is you have significant number of mobile network operators, and everyone has a different interfaces. And if you're a manufacturer of an IoT solution that sits in a consumer device that can be sold anywhere in the world, you don't want to have to deal with each operator, depending knowing where it goes. You want to be able to have a simple solution and it just turns on no matter where it is. And a lot of it depends on where the home market is. And there are multiple options in the home market, and sometimes things go wrong. So there's a lot of issues and challenges in dealing with the connectivity issue, particularly if you're trying to sell products on a global basis. This is the reason why I think the auto guys who are the early users of SIMs in their cars are now turning to players like ourselves who can help them address be able to manage this challenge on a global basis. They don't, like I said, they don't want to have to deal with carriers all around the world. They just want to go to one guy who can manage that one aspect of it for them. Next page. And on the security side, it's going to require, I think, very different architecture, right? And Chris mentioned the zero-touch device onboarding, where you deploy it and it automatically turns on and it works. Doesn't need to require any user inputs on the Wi-Fi passcode or anything as well. We also need to talk about the zero trust access as well. So any connectivity, right? So Chris mentioned the connectivity to figure out to turn on the SIM. But once you turn on the SIM, now the data is being transmitted locally, but also some of it will be transmitted to the cloud. Some of it needs to be transmitted back to the office, to the private cloud. And each one of those connectivity needs to be secured. And in our view, the things need to be designed zero trust first. And the beauty about the Authenta is that you now have a unique identification for every device. So zero trust with the unique identification is ideal match. And now you can, for every time you do a connectivity, you need to be able to authenticate. And because you have the unique ID, you have something to authenticate with at the device level, right? You don't have to worry about anyone else. Actually, at the very root, there's a device that's unique. And it's actually, all of this is embedded. The whole IoT capabilities of the wireless IoT is actually embedded into the silicon, and it becomes a much easier solution for anyone who's trying to deploy these devices, particularly on a global basis. In addition, there needs to be security at the device level itself, right? And depending on how complicated the device, there needs to be something to make sure the firmware is correct, right? So there's different levels of security, but we think that the key thing here, particularly around the connectivity, is the fact that it needs to be designed around a zero trust architecture. Zero touch, zero trust. So if you go to the next page here, we're going to show why we think this is quite complicated, right? Because you're dealing in an ecosystem where you could be having devices, edge IoT devices, on a consumer, like a car, in gaming, consumer appliances, or it could be applied in the field, at the retail store, or in a factory. It could be fielded at the mining in an area out in an industrial area. It could be, then you have to connect all of this to your offices, to your cloud, to your private cloud. It could be, you may need to require to run applications as well as SaaS applications. It needs to be running across the cellular network with various carriers. It needs to be running across the internet as well, right? Because to be able to access certain parts of to be have maximum flexibility and agility to access different clouds. And as a result, all of this requires a global coverage, global service, right? So you have to be able to access any carriers anywhere in the world. You have to have flexibility to be able to integrate with other people's solution, other people's software. And so you need to have a common API. Zero trust, as we mentioned, the whole architecture needs to be done in a way that is zero touch to maximize security. And of course, zero touch, so that it's simple enough so that you don't minimize the interaction with the end user. This is what we think is required, and this is what we've been building towards over the last few years with our Move platform and our Net Foundry, which is a zero trust company. So if you go to the next page, we talk about our platform here, which is about an intelligent mobility platform that manages all the mobility and connectivity on a global basis, right? And so not only does it manages the connectivity using eSIM technology, as Chris mentioned, where we can connect to any wireless operator, but we also have all the tools to be able to provide zero trust onboarding, the zero touch onboarding as well. So all the connectivity is secure. There's a single pane of glass which allows you to see what's going on, be able to have visibility and manageability of what's going on within that network to manage, and also flexibility to have the analytics and to be able to integrate with different analytics platform, like I said, with the API. All of this within a single platform in our Move platform. And so we're very excited about this. We're also very excited about working together with Micron. We think that this solution that we're working together is going to be the new paradigm in being able to accelerate the deployment of IoT. So again, I just want to thank Micron for the opportunity to share this with you. We're very excited about working together, and I think you'll see a demonstration in the next part of the presentation here. So thank you, everyone.